Hello there and welcome to this course on Python Fundamentals for Manufacturing. My name is Valentine and I'll be your course instructor. In this workshop, we are going to follow this structure. We'll start off learning about the learning outcomes of this workshop, which are generally just objectives that to have achieved by the end of the learning experience. After that, we'll get to talk about the Python fundamental concepts in relation to manufacturing that will come in handy. We'll get to talk about why we would want to learn about them. Later, we'll get into a practice session that will entail going through a lot of practice work, whether it's examples in relation to concepts, the Python fundamental concepts, as well as also go through challenges that will allow us to acquire those the skills in relation to those concepts so that we can be able to apply those concepts when it comes to any sort of solution that we might want to create in manufacturing. So we'll go through that practice session, then later towards the very end we'll just talk about the next step. Just as a quick housekeeping, just as a few housekeeping information. If you have any questions, feel free to ask in the comment section. Also, you can pause the video if you feel like we are too fast. That's the beauty about live streaming. You can be able to pause the video, learn at your own pace, as opposed to if we were having this workshop in a meeting, a normal meeting room. And also we will have provided, we actually have provided resources for this workshop in the video description section. So at the point where we get to a practice session, feel free to follow that link in the video description. That will take you to now the resource for this workshop. So let's get started. By the end of today, we expected to have achieved these learning outcomes. We should be able to demonstrate, we should be able to identify the importance of learning Python basics for manufacturing. We should also be able to demonstrate the ability to use Python syntax, so how we write Python, including how to work with variables, data types, and basic arithmetic operations. We should be able to apply that knowledge of data types and variables in Python to be able to also perform just various tasks in relation to manufacturing. We also get to learn about some advanced data types or data structures, if you may call them, that will be lists, tuples, dictionaries, and sets. We'll also be able to use functions, which are just ways of organizing our code that we tend to write in Python. And we'll get to learn a whole lot about what these functions entails, getting to learn about what are parameters in those functions, what are return statements, what are default arguments, as well as learn how to write those functions in an efficient way using what are called lambda functions. We should also be able to implement control structures or loops to be able to bring in conditions within our code. As well as also be able to iterate through a collection of elements. It could be or data items. It could be we might have maybe some collection of related information that we would want to go through. It could be data sets. Then we can use concepts such as loops to be able to iterate through all of that. And the end goal, of course, would be to just perform automation in a sense. So starting off, Python fundamentals for manufacturing generally just refers to those basic concepts and skills that we would use in relation to Python in order to write Python programs. And these Python programs are just a collection of code that we have written in Python. This is the language, programming language that we're going to be working with. And these programs would allow us to automate, optimize, and even just analyze various manufacturing processes and systems. The idea is that we will cover Python fundamentals. We won't go so much into various use cases for Python in relation to manufacturing, such as working with machine learning, or how to perform text processing, or how to perform image analysis. That's a a topic or a course that we can do. But in order to do that particular course or workshop, which we actually will cover in the future, we need to understand these fundamental concepts of variables, data types, printing, arithmetic operators, etc., and take this particular workshop as an entry point. So this workshop is solely tailored for beginners who are looking towards starting their journey. They may or may not have they may have little knowledge when it comes to programming, or no knowledge at all. So this is a workshop or course that's suitable for such kinds of persons. But if you're really interested in other advanced aspects and you're already knowledgeable in these particular fundamentals, then you could always look towards other courses that will produce or have in relation to manufacturing and Python. But this course is generally the entry point of a series of many courses that we are going to be covering. In terms of deliverables, just to mention the kind of work that experts in manufacturing might be able to actualize when it comes to working with Python. They might work on different kinds of projects, and these are just a few. They can use Python, for example, to create what are called scripts. These could be machine monitoring or control scripts that work with control systems or just equipment, and these scripts would monitor and be able to control the various aspects of those equipments and be able to provide the key stakeholders with sufficient information that they can use to make a decision on. In addition, experts with knowledge of Python in manufacturing might be able to wrangle data, not even start import data from different data sources. It could be from the systems that we've talked about, even from sensors. Pull that data, then wrangle it, which just generally entails preparing that data, which, by the way, will be our next workshop in relation to Python and manufacturing. And then once they have been able to clean that data and put it in the right format, they can visualize the data in order to get some key insights. They can also be able to create reports which would provide insights pertaining to some research problem that they might be solving. So data analysis and visualization dashboards would be one of those deliverables that experts with knowledge of Python would be able to work on. There's automated quality inspection systems. These are solutions which would be based on Python that manufacturing experts with knowledge of Python can be able to work on. So they might create solutions that integrate with not only just maybe sensors which collect image data, and then use Python to perform image processing, or even be able to check for quality control aspects, or such as maybe defect detection, especially in cases where there's a whole lot of visual inspection happening manually. That process can be automated through the use of Python, making it a whole lot easier for that aspect of quality assurance to be taken into account. There's predictive maintenance models. So again, the kind of work one might also be able to do is to create solutions that provide these systems that learn from historical data. Maybe it could be that you would want to automate a process in reference to a particular task that normally would take a human being to do. So you can use, say, Python to train what is called a model, which is just a program that learns from historical data that could be maybe on machine performance, maybe on sensor readings data or maintenance logs. and that model can perform a particular task. It could be that it could predict whether maybe a particular piece of equipment will spoil, or maybe a particular piece of product will actually pass maybe some quality control check. So there's a whole lot involving predictive or creation of predictive maintenance models that would also come in handy. Other types of deliverables that one could end up creating would entail would be, let's say, supply chain optimization tools, where you would work with data in relation to supply chain. You could also create models in relation to simulations, process simulations. You could write Python scripts that perform robotic control and automation, or even monitor energy consumption within an organization, and also create solutions that allow for the energy optimization cases, where you might be having just data in relation to energy and would want to maybe determine what's the optimal aspect of this particular aspect of energy consumption. Then you can create Python scripts in reference for that. There are various deliverables. These are just a few. Depending on the research problems that you might be facing or the goals of the organization, then Python can provide that ability to create those particular solutions. Experts that might be involved in use of Python in that process of just in manufacturing would be either industry automation engineers, could be manufacturing data scientists or analysts that look into manufacturing data. They could be quality control engineers or inspectors. There could be operations research analysts, as well as process engineers. And some of these are well versed with hardware that organizations or manufacturing companies use, and what they might be looking towards is just ensuring that they further optimize the process, such that they end up having maybe some processes which are much more efficient than what they currently have. And Python provides a really good medium for being able to, or a solution for being able to create those solutions that they desire. I mean, I've already talked a bit about the reasons why one would want to learn fundamentals, but just to recap, one would be able to use Python to automate various manufacturing processes. They could use Python to gain valuable insights, to be able to automate quality control and inspection tasks, and also be able to develop predictive maintenance models that allow them to be able to identify maybe potential equipment failures, and be able to schedule maintenance before, say, breakdowns occur. So those are just a few. There are many other reasons. The idea here was just to give you a good idea of how Python can be relevant in your journey as a manufacturing expert who's also well versed with working with the Python programming language. At this particular point, we're now going to shift towards learning about those Python fundamentals. And the idea is that you will come out of this learning experience having gotten a grasp of those Python fundamentals and be able to now go into other specific areas that might interest you. But our recommendation after this workshop would be to now, if you are really interested in the data analytics, machine learning side, where you create models, predictive maintenance models, then we would recommend now you go into the data wrangling with Python for manufacturing costs. That will allow you to see how you can interact with data using Python and be able to prepare data for analysis, or be able to identify anomalies within your data set, and fix those anomalies, and or even remove those anomalies or handle them in a certain way that might make sense based on the context that you're working with. So yeah, So at this particular point, we're going to shift to our practice work. So I'm going to ask you to visit the description section of this course or this video, and you should end up to this page. Once you've clicked that resource link, you should end up to this page where you have a sample practice resource, and you can click on that sample practice resource if you just want to explore the course itself. But if you really want to go into learning in an in-depth way, you can consider becoming an afterwork member and going through this particular course using the practice notebook that we've provided, which will provide extensive practice challenges that allow you to acquire the skills in reference to the different concepts that we'll have gone through. So at this particular point, I'm going to ask you to click on the sample resource link, and that should take you to this particular notebook that looks like this. It's a notebook. A notebook generally would be a document that we can use as data analysts or data scientists to share work with others. And it could be data analysis work, machine learning models work. It could be data pre-processing work, depending on whatever project that you're working with. A notebook, again, would also be that document that contains code and also accompanying text that we can be able to have within our document. You can think of it as just a Word document, but now this has the ability to run code that you might have. You can run Python code, and you can also run code in other languages using what are called extensions, which you'd have to install. This document, this notebook we are going to be working on is actually, it resides on Google Drive, and we can access it on the cloud through an app that's called Google Colab. But if you want to install one locally, if you want to be able to work with this notebook locally, you can consider working with a software or an integrated development called Anaconda. And that would allow you to be able to run this notebook locally using what is called Jupyter Notebooks. So, but our focus really is just the learning outcomes. We won't really focus on installation or in troubleshooting of that software when you're installing. So let's not focus so much on that, but let's follow through with the resource that we have. So once you've gotten to this page, just click on File, then Save a Copy in Drive, to save this particular notebook within your Drive, Google Drive, so that you can be able to make future changes or even just be able to have a copy of it for learning purposes. And then once you've done that, it will open in a new tab, so you can close this original one. You don't need this original one. If you just want to just go through, you don't want to go through that step of saving a copy in Drive, just note that you won't have access to this notebook afterwards. But if you save a copy in Drive, you'll have access to this notebook, and you'll be able to save changes if you want to do all of that. Once you've done that, click on Connect to connect this notebook to Google servers, which are going to be running our Python code. It will just say connected, connecting, then connected, and then you should see a green check at the very top right. If you don't do this, if you don't go through this step, you later see a pop-up message when you try to run the code that will tell you that you haven't saved a copy in Drive generally. All right, once you're done, something else to note that's important, a notebook has cells. They're usually what are called code cells and text cells. Code cells usually contain code, Python code. Text cells just contain text. This is a text cell, this is a text cell, but this text cell contains other 35 cells, which some of them are code cells, others are just text cells. On the left-hand side, we have now those different sections within just different sections that we have. You could always click on an area and it will take you to that step. Like if I click on variables and data types, it will take me to variables and data types. And I can use these arrows to navigate. So starting off, the first concept, introduction to Python syntax. We'll start off learning about variables. So to explain the first concept, we are going to think about when we are working with programming languages, we tend to work with data, and that data comes in different forms. data can come in the form of an integer, which is just a whole point number, a whole number. There's float, which is a decimal point number. So those are just data types that I'm mentioning. There's an integer, which is a whole number. There's a float, which is a decimal number, decimal point number. There's a string, which is just generally just some piece of text that you have put in side quotes, in double quotes, or even single quotes. It doesn't really matter. There's also Boolean data type that we can get to work with. These are just some basic data types in Python, or data types are just classifications that we give to data. And it allows us, those classification allows us to be able to later perform operations on those pieces of data. So once we have gotten to understand that data comes in different forms, we also should also get to understand that in order to work with that data, we can store it in a container, a temporary container. So, and in Python, we call that container a variable. In other languages, we also, Python, programming languages, we also call them just variables. But in Python, we can just store maybe a value. Let's say, like in our first instance, we are storing this value 10 inside the variable integer var, and we use the equals operator to store that variable. So we are storing the value 10 inside the integer variable, storing 3.14 inside the float var variable. You're storing the text or string hello world inside the string var variable. In the same, we are also storing the value true inside the Boolean var variable. The value true is it has the Boolean data type, which means you can either have two values, which one could be true or false. It just allows us to be able to efficiently work with the data that we want. So behind the scenes, technically what happens, if I may explain further, when we write Python code, there's a special program that's called a Python interpreter that takes in that code and executes it. And if we have defined that we want to do a certain task, like in our case here, we want to store the values, these values, the 10 to inside the integer, the Python interpreter will actually create those variables and store the respective values. However, we can also provide explanatory notes to our code, which is what we are seeing here in green. So whatever that we put after the hash character will be treated as an explanatory note or a comment. So in our case here, we are explaining that we want to create variables of different data types, which we are doing here. And then we also doing the other thing here, like we are printing the variables. So in order to reveal what's stored inside these variables, we can be able to use the print function. So a function is generally a way, it's just a way of organizing a block of code. And that function, we could decide maybe to write up 10 lines of code that print out maybe the values that we give to that particular function or that particular code. So for example, there's code behind the scenes that prints out whatever that you give it to, and that function is called a print function. We given that function, which is just a collection of code, a name. So we've given it print, and print generally would take in some what we want to print. So the input that we give to a function is usually contained in the parentheses. So the name of the function, then the parentheses, then integer var, that's the name. Then I'm saying that we want to print out integer variable. That's what we're going to print out. The same case, we do the same case for float var, string var, and Boolean var. So what we should see once we run this code is that we are going to see the values of integer var, float var, string var, and Boolean var. This is the pop-up I was saying that if you don't save a copy and drive, you'll get, but don't worry about it as much for now. So what we are seeing here is just an output of the code that we have run here. This is just the console section that we say. It's usually a console section for this particular code cell. And the respective line, let's say the first one, this is as a result of this line, 3.14 is a result of that line. The same case with the others. So yeah, I hope you've learned a few things. You've learned a few concepts. You've learned about data types. You've learned about variables. You've learned also about printing and how to use functions. One more thing that we haven't really learned here is that when it comes to writing the names of variables, there are rules. We cannot just start with any variable name, any character. But conventionally, we start with an underscore. You can Google those rules. There are quite a number of them. But if you just use the approach that we've used here, use maybe the name of the name of a variable that best describes what you're going to be storing. And it can be in lowercase. Don't start with special characters like hashtag or star or $sign. Don't start with that. But in other languages you can. This is just in reference to Python. And if you have multiple words that you want to have as a variable name, you can separate those words using an underscore. That's just an approach that we can use, just a best practice. All right, at this particular point, I'm going to ask you to pause the video and work on this challenge. We've given you just a quick start of how you can work on the challenge. So you can work on that challenge. If you're an Afterwork member, as mentioned, you get more resources. You could always check your solution by going through the challenge. So if you go through the challenge, you'll see that it's already complete. If you're an Afterwork member, then you can verify your solutions for the entire notebook that way. But for the sample notebook, the challenges just finish it almost halfway through the notebook, so you don't get more challenges for that. Okay, pause the video, and once you are done, you can unpause the video and we can continue. Moving on, printing output. I've already talked about that aspect, that concept. So we can print out something using the print function. So we give it an input and then we print it out. But you can even give it multiple inputs. So for example, let's say for example here, this is just a showcase. The examples here just showcase how we can print out whatever input that we've given the print function. But here we can be able to print out, let's say, a string that we have given it, and you can even print out multiple ones, string 2. You can even have a variable that you had already created earlier, like we gave it a variable here, etc. So here we're going to get welcome to manufacturing system, comma string 2, and it will be spaced out with a space. There'll be a space in between. So we generally use a print function to print out something, but we'll get to learn also how to print out also variables inside strings using still a print function. We'll get to talk a whole lot about that. At this particular point, pause the video and work on the challenge. Comments, I've already talked about comments. Comments just allow us to add explanations, and behind the scenes, the Python interpreter, that's the special program that runs Python code, does not run Python comments. So it just skips whatever that comes after the hash. This is just one way of writing comments, but we can also write comments using just delimiter characters, which are just triple quotes, and we enclose the comments in triple quotes. Like this is still a comment, but this is just a much more complex way, and we can have it to be multiple line, like whatever that will come in between those triple characters will be still treated as comments. Like this is still a comment. But for ease of learning, we just use one hash. And you can still have multiple comment lines, like that. These two lines are still comments because they come after the hash. So you can just understand what's happening here. The same case here. It's introducing a new concept that we'll get to talk about in a few. So run that. But the idea here, again, is just to write comments and work on the challenges, the next thing. And then we'll continue. Pause the video, by the way. All right, F strings. So when it comes to working with print functions, and we would want to print out, let's say for example, in our case we have a variable. We have these variables. So these are the variables. Assuming that we wanted to print out the variables. By the way, when you see this one over here, this just means that we are multiplying quantity times, this is a star, unit price to get an outcome. So the outcome, we store it in total cost. So sometimes you might want to print out some text, like here. Even I can use this one. Here we are printing out two things. We are printing out the total number of products, which is a string, and we're also printing out a variable. But assuming we wanted to print out this variable somewhere inside the string, then we can use what is called an F string. So, and an F string starts off by having an F. It could be capital or small. And then we place double quotes to define the string, the start of the string and the end of the string. And then we put our string, and then we define where we want our variable to go using the curly braces. So we want the string product name to appear towards the end of that string. But it could also be even in between, where you want. You shouldn't be limited by that. Yeah, so the same case we do for quantity, unit price, and total cost. And before even you can see that unit price, we have put a small dollar, not a small, just a dollar sign to show that we want to have a dollar sign come before the actual variable place where we want. So this would just be almost like this, only that we put, let's say, as a character symbol in front to just be able to print that out together with the text that we want. Something else also is to note that we can also have, you see where we're saying this is a variable. We can also perform our operations. Let's say we can also add +1. This is what is called, it's usually termed as an expression. So you can do mathematical expressions in there as well. Let's run this. And we can see that we have product, we have quantity, unit price, and also total cost, which is what we have here. All right, moving on, work on the challenge and pause the video once you're done, and you can always continue. And if you're an Afterwork member, you can always verify your solution. Basic arithmetic operations. Sometimes you might want to just perform just basic arithmetic operations, like what we just did here, quantity times unit price, or what we did here, products times hours worked per day. How do we do that? We use what are called arithmetic operators. They're usually either subtraction, multiplication, addition, division. There are also others that we are not going to cover in this session, but the basic ones are the ones that we've mentioned. So you can have two variables, you save their values, you define them, then you perform operation, maybe revenue minus production cost is equals to profit, then you print that out. This is also another way of, without using an F string, by the way, just use a print statement where you have this is the first string and now the variable. All right, at this particular point, pause the video, work on the challenge, and then once you're done, we can continue. All right, data types and variables in Python. So sometimes we've talked about the different data types that we have, which are classifications that we give to data. But sometimes we might want to also, maybe work with, go a bit more and maybe do some operations on maybe strings. Strings are just pieces of information in the form of text, maybe to retrieve maybe the first 4 characters within a string or the last ones. Then we can be able to use the various operations or various approaches. So for example, here we have widget A, which is the value that we store in product name. And to be able to get, say, the first character, we would use the position. So each character within a string has a position, and we usually start from position 0, then position 1, 2, 3, etc. So we can reference the product name, which is now the variable, and then we want to select the character at position 1. We use the square brackets, define the position, and then we'll have that stored in first character. And then we might also decide maybe to convert maybe the entire string into uppercase. Then that would mean that we could decide to reference the product name, then apply the upper function, which will convert the string to uppercase. We can also do the same case with lowercase, just lower. This might be useful when you're doing data cleaning, because you might want to represent data in a cleaner way, or even uppercase would work too. And then we print out first character. This is the variable here, and uppercase name, which is the variable here. You can also modify just a few things and see what happens. You can apply the lower function as well as try a different number. If you try a number that's not within here, you'll get an error. Not within the positions that you have here, you'll get an error. All right, work on the challenge, pause the video, and then you can pause the video, work on the challenge, and then we can continue. At times, we might want to store multiple pieces of information within one variable. Like here, widget A, we are storing just one piece of information. But what if we wanted to have widget A, widget B, widget C inside product names variable? How do we do that? We use either what is called a list or a tuple or even dictionary and sets. So to start off, we'll just get to learn about lists and tuples. A list allows us to store multiple pieces of information within just one container. So we can define how we want to have we can define a list by using square brackets. We have an opening square bracket and a closing square bracket. Then we define our items or elements. Those are the pieces of data that we want to store together. So initially we can use bolt, nut, washer, screw. You could do that. These are just strings. There are 4 items with just which are string nature, but we could also have different data types. You could also have integers or a mix of them, etc. And the strings here, we have single quotes, but you could also use double quotes, doesn't really matter. And whatever that we have here, we store it in this variable. So we have stored this collection inside this variable. And this is a list, because in a list, we usually use a square bracket. But if we want to create a tuple, so in a list, we can be able to modify the items. We can get the first item, replace it with another one. But if we want to store some items and not be able to modify them, we tend to use what is called a tuple. Tuple, you can define a tuple, which is you can define that collection, but you can't modify them, that collection later. So that's the difference between the two. But if you want to retrieve just elements from those different, from either a list or a tuple, you can do so using the same approach. But let's first of all print out the list and print out the manufacturing dimensions tuple. And we can be able to retrieve the items from the list as shown. So we actually still use the same concept for positions. So remember, for the strings, we had position 0, 1, 2, the same thing. For a list, this is position 0, this is position 1, 2, the same case with the tuple, 1, 0, 0, position 1, position 2, 3, etc. And we print them out. And the idea of having a tuple not be modifiable makes it what we tend to say that it is immutable. So if something is mutable, you can be able to change it. But if it's not, you cannot. If it's not updatable, you cannot. You call it immutable. So tuples are immutable while lists are mutable. Pause the video, work on the challenge, and then we can continue. Dictionaries. So here we've seen that we can be able to store multiple collections together. But what if you wanted to store maybe some more information in relation to the items themselves? Let's say, for example, manufacturing parts, then bolts, but we also want to store, let's say, the make. Then nuts, we want to store still the make, or we might want to store some other information, or when that particular bolt was made, etc. So we tend to, when we have such instances, we can use a dictionary. A dictionary allows us to have that extra dimension. It allows us to store data in what are called key and value pairs. So, for example, we might have, let's say, a dictionary called manufacturing data. And inside the dictionary, which we define with curly braces, we have key and value pairs. So this is a key, product ID, and a value. Key and a value, key and a value. So manufacturing data, it could be product ID, then the value for the product ID, and etc. And we could also even have a dictionary or a list as well. Maybe this would be location warehouse A. This could be a list, then warehouse B, warehouse C, if you have multiple locations. So this is a dictionary. It allows us to be able to do the same thing. But And we can be able to retrieve an item from a dictionary by simply referencing the name of the dictionary, then double quotes, then we reference the key. This is a key, and we are able to get that. On the other side, we might want to use sets, which are they're called an unordered collection of unique items. So you might have unique items that you want to store instead of having duplicates. Here you can have bolt, nut. But if you want to have unique items which are not necessarily ordered, then you can use a set. A set doesn't have a key value, so just appears as you can see. So we have curly brace, and we define it more like the way we would with a list, but now, or a tuple, but now we use a curly brace. And yeah, we can be able to check if an element or location exists maybe in a set as using what is called an if statement. So if warehouse A is in this particular manufacturing locations, then we print that. This is something that we're going to learn, if statements, in a short while. But you can run this while learning, just taking that into account. Yeah, so here we are also just going to print out product name. We're going to print out widget A because we want to print out the value of widget A. We're referencing the key here. So widget A, warehouse A, exists in the set. All right, pause the video and work on the challenge. And once you're good to go, then we will continue to the next step. Type conversion. So sometimes you might want to, when we are working with data types, you might want to convert maybe the data type that we have, maybe a piece of data type that's stored in a string, maybe a number. Let's say a number has been stored in a string. Let's say the value 10. We want to convert it. We might want to convert it to an integer so that we can perform mathematical operations. We cannot be able to work with that data as it would be because we would get errors. So let's learn how we can be able to convert or change data types of a variable from one type to the other. So for example, if we wanted to convert maybe a float 10.5 to an integer, we would use the function. So remember, functions usually perform specific tasks. These are just functions are a way of organizing code that performs specific tasks, and functions can take inputs and give you outputs. Or sometimes they might just take an input and do nothing. Or sometimes they could take an input, they might not take an input, or give you an output, but they could run some code behind the scenes. But yeah, for our case, we are going to use the int function, which converts this value into an integer, and we store that integer in this value, in this variable, and we print that variable. We can convert, let's say, an integer into a string. So this, we can convert it into a string if maybe we want to combine this with another string. And then we use the str function for that. And to convert maybe a string to a float, we use the float function for that as well. All right, pause the video, work on the challenge, and when you are done, we can continue to the next section. All right, now we're going to be working with just functions is the next thing. Now, moving on, so functions. So I had mentioned to you, functions are just ways of just organizing code. We have, as you can see already, for a function, we have a name. We can also have not only a name, but we have inputs that we give to a function and also outputs that we get. And that code that we tend to execute is usually contained within a function body. So we'll get to see that. But so far, we have been using built-in functions, and the code for these functions has already been created. But assuming that we had this code that we have here, and we wanted to perform some sort of operation on this code, we wanted to package this as a function, then we can be able to do what we're going to learn how to be able to create our own functions in the next step. So starting off, we can decide maybe to create a function that runs some code that this is the code that we want. Total cost is equals to material cost plus labor cost plus overhead costs. So assuming that we wanted to create a function that runs this code, we would create now the function by using the def keyword and giving the name, giving that function a name. So calculate production cost. And then we define the inputs, how we're going to be able to we define what the piece of information that we're going to be giving to the function. So we define the input, which would be now what we put inside the parentheses. So material cost, comma, labor costs, comma, overhead cost. And how you have this arranged in chronological order is how you're going to be providing your input. So you shouldn't provide material cost where as a second input, or as the third input. So once you have defined this, the values of these particular inputs will then be taken inside the body of the function, and it would be taken into that operation that will be happening inside the function, inside the code that you have. And then we return now the output, which is now the total cost. We use the return keyword to return that. So we will be calling our function just like the way we have called float. Float actually takes str price, which is just one particular input, and then it gives us an output, which is now the form of str price in now a float format. So here we want total to be given out. So once we have defined our function, we can now be able to use it as shown. So first of all, we're just going to define some pieces of input. So we have material, labor, and overhead, which is just reflective of what we have here. And then we can decide to call the function as shown. So calculate production costs, parentheses, then we say material, it's labor and overhead, which will be representative of these values. And then we store the outcome inside total production cost, and we preview that. So if I run this, I should be able to see now total production cost, which is 1800, which will be as a result of the operation that has happened inside the function. So that's the beauty of functions. You're able to achieve so much in a short period of time, and you can reuse this this code anywhere else without rewriting the same code. Assuming that you had hundreds of lines of code, instead of writing that that hundreds of lines of code, you could always just reference a function name and give it some input, and it's going to give you an output. A few things to note is that the definition of our input here, I've been using the word input, but the definition of what we have here when we are defining a function is what we call parameters. So these are called parameters. We have material cost parameter, labor cost parameter, and overhead cost parameter. But then the inputs, or the values of those inputs where we are giving them, so material, labor, and overhead, when we are calling this function, these are not called parameters or variables or inputs. They are called arguments. So what we have here, we are giving our production cost these arguments, and when we define our function, we are creating these parameters. So these are just two terms that you can just keep into account, because sometimes in some text you might come across those terms. So you have these arguments, and you also have parameters here. So also, you need to also take into consideration that in order to use a function, you need to create it first. You need to define it first so that you can be able to use it. By using it, it just means calling it. So here we're just calling the function like we did with floats. Yeah. So already you have to create it first before to call it. If you try to call it or to reference it initially, you won't be able to get it. So then the code needs to come before where you are calling it. All right, let's see, let's now work on the challenge for that. Pause the video, work on the challenge, and then once you're done, you can continue. Default argument. So here I have given you just generally, these are parameters, these are arguments. But sometimes you might want to ensure that maybe you have overhead cost as constant, so that it might be just something that's constant throughout. And you just so that people might only give material and labor as the two values, and automatically overhead cost will be just a constant. We could decide to put it here. Sometimes we might even decide to put it as a variable before the line of code that is inside our body. And also our body of our function usually has an indent. So take into account of this in space that you have here. It has to be indented. So you can put two tabs or just space, has to be space so that you have this as a body. So we might decide to define the some default arguments or some constants as shown. So product name, then quantity. This is now the default argument. So when we give when we give a function, maybe let's say when we call the function, so here we are creating assemble product function, we're giving it 2 values, and what's happening inside the function is this. We're not returning anything, we're just printing out assembling, then quantity, which will be 1, then product name, which would be now what we will have given it. So we might decide, let's say, to call the function with only the required argument. So this is the required argument, which is car product name. So assembling, it will be assembling car units of quantity of just 1. So if I just run that, so I can see assembling quantity, sorry, assembling quantity, assembling 1 unit of car. So, and the next one would be assembling 10 units, because you can override the original, the default number, assembling 10 units of product of toy, because you've defined it as that. So you can still be able to override the default arguments if you want. All right. At this particular point, pause the video and you can continue once you have worked on the challenge. Variable scope. Sometimes you might want to work with variables that are inside the functions, and variables inside the functions cannot be accessed from outside the function. But that's what we are referring to as variable scope. So if we create, let's say, this function and we define this variable, you can't access this variable from outside. But if you want, you can always create, you can have a variable outside. Variables that are inside functions, we call them as local variables. And because they are local to that function, and variables that are outside are usually called global functions, and you can access them even from inside this particular function. So you can access machine speed from inside this particular function. And yeah, so that's what we do. Let's run this just to define that. And you can also now work on the challenge, and then we can continue. Lambda functions. So lambda functions are just a way of just writing functions in an easier way. And they allow us to be able to maybe pass a function as an argument to another function. But generally they just allow you to just have, just to write functions in an easier way, I would say. So how we define a function, so it's still the same concepts. You give a function a name, so which we give here, calculate total cost. We use an equal sign, and then we use a lambda expression, and then we say quantity and unit cost will be the inputs or the parameters, and quantity times cost within one line will now be the code that will perform the body of the function itself. So it's, you can write this lambda function is actually this format, but this is just an efficient way of just writing a function. And then we now call the function like we would with other functions: calculate total cost, quantity, unit cost, to define the arguments, and then we just call it here. And by default, whatever that comes here will be returned by the lambda function. Pause the video and then we can continue to the next step. This is saying working with functions, but it should be working with if statement, working with control statements and loops. I'll update that in the notebook, so once you get here, you shouldn't be worried so much about that. I'll update that in the original notebook. So yeah, so I'll cover this part of this. I won't cover the entire bit, but I'll let you to continue working on the rest, by the way. So yeah, sometimes you might want to work with control statements to check for values, if values exist within maybe a variable, a list, or a dictionary. And if it does exist, maybe perform some certain operation, maybe for data cleaning purposes or for other purposes. Then that's where control statements such as if, else, nested if, elif, for loops, and while loops come in. So we'll start off with if else statement. So we will actually use functions that we have actually used before. So starting off, we can decide to create this function, check production status, and we give it an input, and we use an if statement. If the value of this machine status is equals to running, then print production, then this particular code that comes an indent from the if statement will be executed, and you can have multiple lines of code, else this will be executed. We're not returning anything here, we're just printing out. Sometimes this is just a bit complex, it just involves using now the functions, but you can also rewrite this as just something like this, else. Let me just put it back. It could always be something like what you're seeing here, but you need to have machine starters as maybe running to just have a function before, and you can always rewrite it as that. But this is just for ease of understanding how we can integrate functions into just if-else statements. So run this, and you can see that if you run this, we pass running to machine status. Then if machine status is equal to running, then we print out that. If this is a number, then here we can decide to have, let's say, different operators. This is an expression. If keyword, then an expression. Expression can be is equal to running. It could also be, if it's a number, less than. If machine status is less than a number, or greater than a number, or greater than or equal to, or less than or equal to, or not equal to. Those are just different operators that we can use. But for now, just go back to the two equal signs. Pause the video, work on the challenge, and once you're done, we can continue. Nested if just means maybe if you also have an if statement inside this if statement to also check for another if statement. So here we're not using functions, we're just using nested if. So we have this if statements. Initially, we are creating these two variables. This if statement, then we have another if statement inside, if else statement, and then another if else inside the else part. So yeah, so and just beware of the indents. So the code that comes an indent from, let's say, this line over here will actually be for this particular expression. If this turns out to be true, then the code here will be executed, else this will be executed. So run that. And once you're done, I've understood that, you can always review the notes. Then you can work on the challenge, and then we can continue. You can also use an elif. So instead, if you wanted to have another condition, you can always add a second condition. Let's say you can write elif instead of temperature greater than 70. Maybe you wanted to check if it's greater than also or equal to 70. You can also check it as that. Here it's less than 70. And you can also tie another condition as shown. You have another condition. You put a double colon. But both of these have to be true in order for this statement to be executed. But if you want just one to be true, you can just use an or operator. So, so that's just a bit about that. Run that, and then pause the video if you and then you can work on the challenge. I'll just go through the last concept, then you can go through the rest of the concepts by yourself. For loops allow us to iterate through, let's say, a collection of elements. So assuming we have this list and we wanted to go through each and every element and maybe retrieve one or two or apply some operation, we can use a for loop. So we have a for keyword. Then we have a variable that will contain the current value of the iteration that we are in. Then we define whatever collection that we are iterating through the use of the in keyword. Then inside the for loop, we have a body where we are printing out the current item. Let's say working on, let's say machine, the first iteration, lathe, then second iteration, milling machine, etc. While loops usually have, you can pause the video but then work on the challenge. While loops usually have a condition that needs to be true. So this needs to be true in order for the loops to be continue looping, as opposed to a for loop which iterates through all over. So a while loop just allows us to be able to, first of all, have this as true. If this is true, then you'll be able to execute what comes in the body statement. If not, it will not. This expression is just, we can rewrite it as, let me just put a comment. It's just a short form of what we have here. It's product produced is equals to product produced plus 1. This is just a short form of this. All right, at this particular point, I'm going to let you continue working on the rest of the content. I hope you are able to learn a lot from this course. Use the explanatory notes and get to learn the most out of it. See you in the next video, and if you have